Alright, this is going to be your review for Friday's test. My copy is kind of dark here. This row is knows how to swim, doesn't know how to swim, and the total, knows how to ride a bike, doesn't know how to ride a bike, and the total, and then they're all filled in. First we want to find the probability that any one of these knows how to swim. So since these are regular probabilities, we need to know the number of people who know how to swim. And then divide that by our total, which is our grand total. So here, everyone who knows how to swim, that total is 40 from the table. And then the grand total of however many students there are is 60. So we have 40 divided by 60. From here we're going to want to reduce, so we'll divide by 20 to top and bottom. So 40 divided by 20 is 2, and 60 divided by 20 is 3. So we end up with 2 over 3. And 2 over 3 is about 66.7%. So of the 60, 66.7 know how to swim. Okay. Number 2 and number 3 are similar. So you're just looking at doesn't know how to ride a bike. The total of that, divide that by the grand total of however many people there are. Same thing for number 3. So you guys can practice those two. Number 4, this is conditional probability. How we read this is a probability that the person doesn't swim, given that they don't know how to ride a bike. Okay, so we're given this piece of information, and of the people that don't know how to ride a bike, what's the percentage of people who also don't swim? So what we're going to do here is find the number of people who don't swim, and this upside down U is intersection, so it also means and. Don't swim and don't ride bike. And we're going to divide that not by our grand total, but the total amount of people that don't know how to ride a bike. Don't ride bike. So looking at our table, don't know how to swim and don't ride a bike is 5. And the total that don't know how to ride a bike, doesn't know how to ride a bike, is 15. So that's our denominator. So if we divide by 5, we end up with 1 over 3, and that is about 33%. 33% of the people who don't know how to ride a bike also don't know how to swim. Okay, and you guys can do number 5 as practice. For this one, they know how to ride a bike given that they don't know how to swim. So this given information is going to be your denominator, and your numerator is where they overlap. Okay. So you go to the store and buy the following items: M&M's, Skittles, Reese's, Starburst, Twix, Snickers, and Jolly Ranchers. So set A is items made of chocolate. Set B is the items that are spherical. Set C are the items that are colorful. Okay. So for these guys, we're going to find the following: intersections. We have some unions, complement, asking is A a subset of B, probabilities down here, using the information that you find from the previous ones. So I find that highlighting makes things a little bit easier to see. So all the items that are made of chocolate, we have M&M's, Reese's, Twix, and Snickers. That's everything that's made of chocolate, and that's going to be in for A. M&M's, Reese's, Twix, and Snickers. Okay, all the items that are spherical, so everything that's like a circular shape, M&Ms are circular, so we'll put that there. I'll circle. Skittles are circular. Reese's are circular. Starbursts are squares. Twix are not circular. Snickers and Jolly Ranchers. So Snickers are bars and Jolly Ranchers aren't spherical, so just those three. M&Ms, Skittles, and Reese's. And then C are all the items that are colorful. So Jolly Ranchers are colorful. I'll underline those. Jolly Ranchers, M&Ms, Skittles, Starburst. M&Ms, Skittles, Starburst, and Jolly Ranchers. Okay, so to find the intersection of A and B, intersection is what they have in common. A intersect B. So what does A have in common with B? They have M&Ms and Reese's. Okay. So for number 7, you find that intersection. Same thing for number 8. What do A and C have in common? And then you're writing out that set. So 7 and 8 are intersections. Number 9 is a union. So the set A is going to be union with C. A union C. And it's like A and C are getting married, but we don't allow duplicates. So M&Ms are in both. Reese's. Twix. Snickers. Skittles, Starburst, and Jolly Ranchers. Skittles, Starburst, and Jolly Ranchers. Okay, that's union. 10, the complement. B complement. So complement is everything that is not inside of B. So if I look at my B bubble here, I have M&Ms, Skittles, and Reese's. I want everything else in the universe that it's not those three things. So we're going to have Starburst, Burst. We're going to have Twix. We're going to have Snickers and Jolly Ranchers. So that's complement. Number 11 is A subset of B? So what this is asking is A completely contained in B? Which also means, is A completely inside of B? Or is all the elements that A has are also in B? And this would be a no. Because set A has M&Ms, Reese's, Twix, and Snickers, and there's stuff that's missing. A has more things than B does, so all the things that A has are not inside of B. Not a subset. Number 12 is a similar question, but we're looking at sets B and C. Probability of A. Number 13. Probability is how many items A has divided by the number of things in our universe or our total. So A has 1, 2, 3, 4 items, and then our universe is 1, 2, 3, 4, 5, 6, 7 items. So 4 over 7 is our probability for that one. And very similar, find how many items are in all the other ones divided by the universe to find the probabilities of those. Okay, on the back side, a bag contains 10 quarters, 20 dimes, 50 nickels, and 100 pennies. You randomly choose a coin with replacement. With replacement means once we take an item out of the bag, we're going to put it back in. So first, let's find how many things we have total. Our total, how many items are in here? We got 10, 20, 50, and 100. So 150, 170, 180. What is the probability that you get to pick a quarter? So picking a quarter, probability of a quarter, is the number of quarters that you have divided by the number of things in your total. So how many quarters do we have? We have 10 quarters. And then how many items do we have total? 180. Divide by 10 to simplify. We end up with 1 over 18. Okay. What is the probability of picking a dime first and then a penny next? So this is multiplication rule. We're finding individual probabilities. First you pick a dime, and then you put the dime back, and then you pick a penny. And you want to use multiplication rule for this one. Okay, so you guys can do number 18. Remember, multiplication rule, probability of A times probability of B, if you're trying to find the probability of picking a dime first and then a penny. Number 19, what is the probability of choosing a coin that's not a penny? So we'll probably want to use the complement here. Probability of choosing a coin that's not a penny. What we can do is 1 minus picking the probability of picking a penny is the same thing as probability of not penny, the complement. So find the probability of finding a penny or choosing a penny, do 1 minus that probability, and you're going to have this question answered. Number 20, what is the probability of choosing a coin that's not a penny and then a nickel? So whatever you got from 19, multiply that with the probability of finding a nickel. Multiplication rule again for that one. Okay, for a set of cards, find the following probabilities. In a deck, there are 52 cards. Okay, we have 4 suits. 2 suits are red, and 2 suits are black. The suits that are red are the hearts and the diamonds, and the black ones are the spades and the clubs. Okay. Of these 4 suits, there's 13 of each type. So there's 13 hearts, 13 diamonds, 13 spades, and 13 clubs. And these 13 cards are the ones that are listed here: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Okay. The probability of face cards in this case are the cards that have like a little face on them. So the jack, queen, and king are the only cards that have a face. All the other ones are numbers. So the probability of a face card, well, I have 3 faces, 3, 3, 3, 3, 6, 9, 12. I have 12 face cards. Number of face cards divided by the number of our whole deck. So how many face cards are there? We know there's 3, 6, 9, 12, and then the whole deck has 52 cards. I could probably divide by 4 here. So 12 divided by 4 is 3, 52 divided by 4 is 13. There's my probability. Finding a club is the same we know there are 13 clubs, a face card and a black. So the face card has to be black. So we know that there's 12 face cards, half of them are red and half of them are black. 24, this is 21, 24 is conditional probability, the probability that you pick a club given that you're picking a number card. So a number card are just the cards that have a number on them. So 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 9 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 number cards. But there's 9 of each kind. So 9 plus 9 plus 9 plus 9. 9, 18, 27, 36. There are 36 number cards. Of those number cards, how many are clubs? So I have 36 number cards. 9 are clubs. So the probability of club, given that it's a number card, is going to be the amount of number cards that we have, which is number card. And then how many number cards are also clubs? So I have 9 that are clubs and 36 to pick from. I can divide by 9, end up with 1/4. Same thing for 25, that's conditional probability. A number card given that it's a club. The only difference is going to be the denominator, how many clubs you have. Okay, I suggest you guys go through the study guide a couple of times, go through your notes, finish working on whatever practice you haven't completed, and make sure you have everything done and ready to turn in.